An asteroid belt is a region in space, primarily located between the orbits of Mars and Jupiter, where a large number of small celestial objects, known as asteroids, orbit the Sun. These objects vary widely in size, composition, and shape, and they are remnants from the early solar system. The asteroid belt provides a fascinating insight into the formation and evolution of our solar system and serves as a unique area of study for astronomers. In this comprehensive explanation, we will explore the characteristics of the asteroid belt, its formation, the types of asteroids it contains, its importance in understanding the history of the solar system, and the significance it holds for future space exploration. The asteroid belt is a vast region of space that lies between the orbits of the planets Mars and Jupiter. It is home to a large number of rocky bodies called asteroids, which vary in size from small boulders to objects hundreds of kilometers in diameter. These asteroids are composed mainly of rock and metal and are thought to be remnants of the early solar system, dating back over 4.5 billion years. Although the asteroid belt contains a significant number of asteroids, it is not as densely populated as one might expect. The objects in the belt are spread out over a large region of space, and the distance between individual asteroids is vast. The total mass of all the asteroids in the belt is only about 4% of the mass of the Moon, which highlights how relatively empty the asteroid belt is, despite containing millions of objects. The asteroid belt is located between the orbits of Mars and Jupiter, approximately 2.1 to 3.3 astronomical units, AU, from the Sun. 1 AU is the average distance from the Earth to the Sun, roughly 93 million miles, 150 million kilometers. The asteroid belt spans a region of space that is roughly 100 million kilometers wide. The belt is not a solid structure or a collection of clumps of asteroids all orbiting in perfect alignment. Rather, the asteroids are scattered across a vast region of space. The distance between the objects in the asteroid belt can be enormous. For example, the average distance between two asteroids can be tens of thousands of kilometers. The asteroid belt is thought to be the remnants of a planetesimal population that never coalesced into a full-fledged planet. In the early solar system, billions of years ago, the gravitational pull of Jupiter played a significant role in preventing the objects in the asteroid belt from forming a planet. The process of planet formation begins with the condensation of dust and gas in a protoplanetary disk around a young star. In this disk, particles collide and stick together, forming larger and larger bodies, eventually leading to the creation of planets. However, in the region between Mars and Jupiter, the presence of Jupiter's strong gravitational field caused perturbations in the orbits of smaller bodies, preventing them from clumping together to form a planet. Jupiter's gravity is so strong that it creates a resonance effect in the asteroid belt, where the orbits of some of the objects are affected by Jupiter's position. This resonance helps to maintain the belt structure, keeping the asteroids in their current orbits. Over time, the larger bodies in the belt were either ejected from the region or collided with each other, leaving behind a population of smaller asteroids. Asteroids in the asteroid belt come in a wide variety of shapes, sizes, and compositions. Based on their composition, asteroids are classified into three main types: carbonaceous, C-type, silicate, S-type, and metallic, M-type. Each type of asteroid provides valuable information about the early solar system and the processes that shaped it. C-type asteroids, also known as carbonaceous asteroids, make up the majority of the objects in the asteroid belt, about 75%. These asteroids are rich in carbon and contain a mixture of rock and organic compounds. C-type asteroids are typically dark in appearance and have low reflectivity. They are believed to be composed of the same materials that existed in the early solar nebula. The cloud of gas and dust that surrounded the young sun. C-type asteroids are considered to be some of the most primitive bodies in the solar system, preserving the original building blocks of the solar system. Studying these asteroids can provide insights into the early conditions and processes that led to the formation of the planets. S-type asteroids, or silicate asteroids, make up about 17% of the asteroids in the asteroid belt. These asteroids are composed primarily of silicate rock, including materials like olivine and pyroxene. S-type asteroids are generally brighter than C-type asteroids and reflect more light. They are typically made up of rocky material that has undergone some degree of differentiation, meaning that they have been heated and processed over time. S-type asteroids are believed to be remnants of the early solar system that underwent partial melting, which allowed for the separation of materials into distinct layers. These asteroids provide valuable information about the processes that occurred during the early history of the solar system. M-type asteroids, or metallic asteroids, make up a smaller portion of the asteroid belt, about 8%. These asteroids are composed primarily of metal, particularly iron and nickel. M-type asteroids are often brighter than both C-type and S-type asteroids, and are thought to be the remnants of the cores of differentiated planetesimals that were shattered by collisions. The study of M-type asteroids is important because they may represent a direct link to the cores of planets and provide information about the processes of planetary differentiation. Some of the largest asteroids in the asteroid belt, such as 16 Psyche, are believed to be M-type asteroids. While the asteroid belt is filled with millions of asteroids, there are a few particularly large and notable objects that stand out. Some of the largest asteroids in the belt include Ceres, which is the largest object in the asteroid belt, with a diameter of about 940 kilometers. It is classified as a dwarf planet and is located in the inner region of the asteroid belt. Ceres is unique because it contains a significant amount of water ice and is believed to have a subsurface ocean. In 2015, NASA's Dawn mission became the first spacecraft to visit Ceres, providing valuable data about its composition and potential for supporting life. Next is Vesta, the second largest asteroid in the asteroid belt, with a diameter of about 525 kilometers. Vesta is a large, rocky asteroid that has a differentiated interior, meaning it has undergone a process of melting and separation into different layers. Vesta is one of the brightest objects in the asteroid belt and is thought to be the source of some meteorites that have fallen to Earth. NASA's Dawn mission also visited Vesta in 2011, providing detailed images and data about its surface and composition. Finally, we have Pallas, another large asteroid in the belt, with a diameter of about 512 kilometers. It is a slightly more irregularly shaped object than Ceres and Vesta and is made up primarily of rock and metal. Pallas is thought to be a remnant from the early solar system that has remained relatively unchanged over billions of years. The asteroid belt holds significant scientific value because it provides a snapshot of the early solar system. The objects in the belt are thought to be remnants of the planetesimal population that never formed into a planet, and studying these objects can offer insights into the conditions and processes that existed during the formation of the solar system. The asteroid belt also plays a crucial role in understanding the dynamics of the solar system. The gravitational interactions between the planets, particularly Jupiter, have shaped the structure of the asteroid belt and influenced the orbits of the objects within it. These interactions are an important factor in understanding the formation of the planets and the evolution of the solar system. Furthermore, the asteroid belt is of particular interest for future space exploration. Asteroids are seen as potential sources of valuable materials, including metals and water, which could be used for future space missions. The study of asteroids could also provide clues about the origins of life, as some asteroids contain organic molecules that may have played a role in the formation of life on Earth. In recent years, there's been growing interest in exploring the asteroid belt and its potential resources. Space agencies such as NASA, the European Space Agency, and private companies have been developing missions to explore asteroids and even extract materials from them. One of the most ambitious missions is NASA's OSIRIS-REx mission, which successfully collected a sample from the asteroid Bennu and returned it to Earth in 2023. This mission will provide scientists with valuable data about the composition of asteroids and the early solar system. In addition to scientific exploration, there is also increasing interest in the potential economic value of asteroids. The asteroid belt contains vast amounts of materials, including metals such as platinum, gold, and iron, as well as water, which could be used for fuel and life support systems on future space missions. As technology advances, asteroid mining may become a viable industry in the coming decades.
The asteroid belt is a fascinating region of space that provides valuable insights into the early history and evolution of our solar system. Composed of millions of asteroids, ranging from small boulders to large rocky bodies. The belt is a remnant of the planetesimal population that failed to coalesce into a planet. The asteroid belt contains a variety of objects, including carbonaceous, silicate, and metallic asteroids, each of which provides unique information about the early solar system. As space exploration continues to advance, the asteroid belt will play an increasingly important role in our understanding of the solar system and the potential for future space exploration. The study of asteroids can help us learn more about the origins of the solar system, the processes that shape the planets, and the resources that may one day be used to support human space missions. In the future, the asteroid belt could become a key target for exploration and exploitation, offering both scientific discoveries and valuable resources that could benefit humanity.